All right, pre-cal 11, let's get after it. Here we go, video number 8. We are solving radicals. So, before we get into solving, we need to understand restrictions, so domain restrictions. So now remember, we're only going to be solving square roots in this section. If you have a perfect square, you are not allowed to have a negative number underneath. No, no, not allowed. It doesn't exist. You can't have that. So if you look at something like this, root x plus 2, you have a restriction on what x is allowed to be because x plus 2 is not allowed to be negative. It has to be greater than 0. Now it can be equal to 0, so greater than or equal to 0. And that is what sets your domain restriction. So solve that. Subtract 2 on both sides. X has to be greater than or equal to negative 2. So if you consider that on a number line, if this is negative 2, this answer is allowed, and so is anything going that way. If you think about that graphically, which you'll see in grade 12, your graph will exist at negative 2 and that direction only, because it can't exist over here because x is not allowed to be negative. So that is what it means to be a domain restriction. So all of these will have domain restrictions. And if you have one radical, you only need to worry about the one thing, this. The other x doesn't matter. There's no restrictions on this x. It can be anything it wants. But it also has to follow in line with what that restriction tells us. And all you're doing is you're taking what's underneath the radical, you're putting it into the inequality, greater than or equal, oh, I don't like that, one sec, greater than or equal to 0, and you're solving. So add 3 to both sides, 2x is greater than or equal to 3, divide both sides by 2, 2x is greater than or equal to 3 over 2, which means, again, number line, here's your 3 over 2, your 1.5. Your solutions will be there or bigger. Graphically, we would exist at 1.5, and our graph would move that way, because it can't be anything less, because then it doesn't exist. So this x here does have to follow the same rule, but it doesn't set any potential rule for us. What I mean by that is this. In this scenario, we have 2 radicals, which means we're going to have 2 restrictions. So we're solving this one, and we are solving this one. So first, minus 4 on both sides. You get 3x is greater than or equal to negative 4, and then x is greater than or equal to negative 4 over 3. So number line wise, here's 0, here's negative 4 over 3. X exists going this way. Now for the other one, we're going to add 4 to both sides, so x is greater than or equal to 4. X is greater than or equal to 2 when we divide both sides by 2. So if 2's up here, it means this one doesn't actually start till here. So what that does is that sets us up with 2 areas of restriction. Now, this line is going to continue along, right? But what we're looking for is we're looking for values that will satisfy both, and that doesn't actually start until this point here. So all of these values of x will satisfy one of the restrictions, but not both. We need to satisfy both. So the only restriction that actually matters is that x is greater than or equal to 2. So when you have that scenario, you only have one restriction, and it's whichever one covers both scenarios. Here's one more for restrictions, and then you should get the hang of it. Now, in this case, we need to make sure that x is greater than or equal to, x plus 3 is greater than or equal to 0, so x is greater than or equal to negative 3. So number line. Here's negative 3. That's my first one. Now, the second one, you got to be a little bit careful with your inequality rules, but there's 2 ways you can do this. X needs to be positive, so let's just add x to both sides. So this one gives us 1 is greater than or equal to x, or x is less than or equal to 1 if you just flip it. Now, if you were to solve this inequality the other way, if you subtracted 1 from both sides, you'd have that. And then you'd have to divide or multiply both sides by negative 1. And there's a rule in our inequality realm that if you multiply by a negative, you flip the inequality. So either way, we end up with the right one. But look what happens here. The second inequality gives us this restriction. So herein lies a moment where we have a bunch of answers over here, we have a bunch of answers over here, but the only ones that are covered by both are the ones in between here, which gives us a domain restriction where x has to be greater than or equal to -3, but also less than or equal to 1. So only numbers in between those two will satisfy that equation. Everything else will not exist. Graphically, you would have a graph that looked something like this, right? There would be some sort of graph in here. It would do something, but it would stop because it only exists in between those 2 points. It does not exist out here, it does not exist out here. And you'll get into graphing more and more as your math continues on. We might even look at some for fun this year. But now let's look at solving these things. So solving and then looking for what we call extraneous solutions. So extraneous solutions are solutions that are potentially true algebraically, but break rules with respect to either our domain restriction or our original equation. Because in order to solve these, first, what is our domain restriction? X plus 1 has to be greater than or equal to 0, so we know that x has to be greater than or equal to -1. So if we get any answers that do not satisfy that inequality, we can reject them right off the bat. The other thing, when we solve this, we need to solve for x. So the first thing we do is, how do you get rid of a square or a square root? You square. So we're going to square that side of the equation, and we're going to square that side of the equation. But that act of squaring creates potential extraneous solutions because when we square root, you know how we can end up with a plus or minus? Well, if we've squared it, the algebra doesn't know if we had plus or minus. So it has the potential to create what were known as extraneous solutions. So we just check them at the end. So let's do this. We square both sides, we get x plus 1. And now be really careful here. This isn't x squared minus 1 squared. It's x minus 1 squared. So x minus 1 times x minus 1. So we FOIL that out, and now we have x plus 1 equals x squared minus 2x plus 1. Subtract 1 from both sides, subtract x from both sides. And now we have 0 equals x squared minus 3x. So we're going to solve for 0. That's what we're going for. So we'll factor out an x. And we end up with two potentials. X equals 0, so that would be this case here, because if that's 0, the whole side's 0. Or x equals 3, because if x is 3 here, that's 0, and the whole thing's 0. So those are our two potential solutions. What we have to do is we need to take our original equation, we need to plug in our solutions and see if it stays true. So if x is 3, 3 plus 1, and then 3 minus 1. So 3 plus 1 is 4. The square root of 4 should be equal to 3 minus 1. 2 equals 2. Yes. So that is a solution in fact. Now when x is 0, we get 0 plus 1 should be equal to 0 minus 1. Well, now we have a problem. The square root of 1 equals -1. That's not possible. 1 does not equal -1. So we reject that solution and we only take that one. So that is how you check for your extraneous solutions. Now, in your head, you might be saying, well, wait a minute, the square root of 1 is plus or minus 1. Yeah, but remember from the first video, if this was negative, they would have put a negative in front of it to begin with. So we assume that the square root here given is a positive answer. So 1 is not -1. Let's look at another one. So here we're going to have two domain restrictions. 2x plus 5 has to be greater than or equal to 0. 2x has to be greater than or equal to -5. X has to be greater than or equal to -5 over 2. And then we have x minus 1 has to be greater than or equal to 0, so x has to be greater than or equal to 1. Now, only this one satisfies both, so that is our important domain restriction. So we'll start there. And now we'll solve. Now, it's helpful in this scenario to not have both roots on the same side, because if you squared this, you'd have to FOIL it, and it's going to get big and messy. So what we'll do is we'll add this to one side, and we'll add it to this side. Now, this one's still going to get kind of messy, but not awful. So now we have root 2x plus 5 equals 2 plus root x minus 1. Now, when you square both sides, you have to do that. So now you're going to have 2x plus 5, so the one root is gone, but now you have 2 plus x minus 1 times itself. Now, when you FOIL this, the 2 times 2 is 4, but then you get 2 times root x plus 1, so 2 root x plus 1, or sorry, x minus 1. And then plus 2 root x minus 1. But then when you multiply the root by the root, they just cancel out, so we end up with plus x minus 1. Now, if you had minus there, I'd show you a little, you'd want to put brackets around whatever was under your root to make sure you took care of it properly, but it's not the end of the world in this scenario. And now what we will do is we'll simplify in groups. So we have 2x plus 5 equals, well, this 4 can subtract with this 1, so 3, and then plus 4 times x minus 1 rooted plus x. Now what you want to do is you want to get everything onto one side of the equation except for the root. So we'll subtract 3 from this side and subtract x from this side. Subtract x, subtract 3. And now we have x plus 2 equals 4 times root x minus 1. So we got to keep going. We're going to have to square it again. So now we're going to square this side and we're going to square this side. And since this 4 is multiplying, we will square it. So now we have x plus 2 times x plus 2, and then 16 and then times, because this squared squares that and then squares that, so breaks the root, 16 times x minus 1. Now let's work through this FOIL. X squared plus 4x plus 4, and then equals, water bomb, 16x minus 16. Get everything together on the same side of the equals sign here. So minus 16x plus 16 minus 16x plus 16. We get x squared minus 12x plus 20 equals 0. And here's why we did all that extra practice of factoring. We get x minus, two numbers multiplied to 20 and add to 12, 10 and 2. So x minus 10, x minus 2. So herein, we get two solutions. We get x equals 2, and we get x equals 10. Now remember, those are potential solutions. We got to try them out. So I'm going to erase some of this now. We've done all the hard work. And we just need to look at our original statement. If I threw a 2 in for x, I would have 2 times 2 plus 5 minus the square root of 2 minus 1. So this is what I would have, should equal 2. So that's the square root of 9 minus the square root of 1 should equal 2. And that's 3 minus 1. So we're good. So x equals 2 is good. And then you got to do the same thing now for 10. So this time, x is 10. So 2 times 10 is 20, so 20 plus 5, minus the square root of 10 minus 1. So we get root 25 minus root 9 should give us 2, and that's 5 minus 3. So this one works too. So in this case, both solutions work. We take them both. There's a lot going on here. Watch this video, rewind it if you got to see these steps a bit slower, but also it's in the notes in a really organized fashion. So these are fully loaded. There's a lot happening. You got to check your domain restrictions. You got to check your extraneous solutions. Be very tedious and take your time on them. But the notes really show it nicely step by step here, 2.5 solving radicals. Thank you so much. I'll see you next time.